7.5 notes is Euler's method. This is a purely BC topic. In the next lesson, we're going to learn how to find the solution to the differential equation, but in this lesson, we're going to learn to approximate the solution. This approximation is called Euler's method. So the process for the approximation is using a bunch of tangent lines to approximate the solution. Okay, so number 1 says dy dx is equal to 1 plus y, and y of 0 is equal to 0, and the change of x is equal to 0.5. Well, that change of x represents the steps. So it says, using Euler's method, show an approximation to the curve y is equal to f of x. So our first step is to construct a tangent line at the point 0, 0 on the interval 0 to 0.5. Okay. Notice that since our step is 0.5, our interval is going up by 0.5, 0 to 0.5. Well, since we already know that dy dx is 1 plus y, I can plug in my y value of 0 and I get my slope of 1. Then I use the point slope formula, plug everything in, and I get my equation y is equal to x. Okay. What this gives me is that from my starting point, I'm able to get a new point, and that point is 0.5, 0.5. So I'm going to repeat this process again. So now I'm constructing a tangent line with this point, and then notice on my interval, I am now up another 0.5, so 0.5 to 1. So here is my dy dx. Now I'm plugging in 0.5 for y to get my slope of 1.5. Use the tangent line, plug in all my information, and I get this equation for y. I'm going to plug in x is equal to 1 based off of these bounds, and then I get the y value of 1.25, which means I go from 0.5 to 1, 1.25. And then I do that process one more time. So I have dy dx is equal to 1 plus y. I plug in 1.25 for my y and get 2.25 for my slope. Do my point slope formula, and I end up with y is equal to 2.25x minus 1. Plug in my bound of 1.5 in for x, and I get y is equal to 2.375. So that ends up with my answer, my new point of 1.5, 2.375. So with all those points, and I highlighted them in green, so starting with 0, 0 and ending in 1.5, 2.375, I actually can plot those points here. Okay, so here are all those points. And if I connect them, those are my tangent lines. So for example, here was one tangent line. Okay, here is another tangent line, so on and so forth. So I created 3 tangent lines that eventually will approximate that curve that I highlighted in green, following the slopes on my slope field. So this method right here is not necessarily how you will see it on an AP question, but instead how you will just see the very general basis of how Euler's method works. So number 2 is actually how Euler's method is going to appear on the AP exam. So number 2 says dy dx is equal to 2x, and let f of x equal y be a solution to the differential equation. If f of 1 is equal to 3, what is the approximation of f of 2 attained using Euler's method with 5 steps of equal size? So notice I highlighted f of 1, f of 2, and 5 steps of equal size. We're going to use that information to find the step size, or the change in x. And when I plug in those numbers here, I get 1/5, or in other words, 0.2. Using the idea of the point slope formula for the tangent line, this actually leads me to my formula for Euler's method, and that is new y is equal to y1 plus y prime times the change in x. So when I fill in this table here, notice that my x's, I started with 1 because I was given that f of 1 is equal to 3. And then since my steps were 0.2, I went up by 0.2 until I got to f of 2, and that is the value I'm trying to approximate. So starting at the top of the table, I already was given this point. I need to find y prime, and I'm given dy dx, and dy dx states that I take 2 times x. So 2 times 1 gives me 2. For my new y, I use the formula I wrote in red, and so I take y1, which is my original y here, plus y prime, which is the value I got here, times the change in x, which is 0.2. And then I get a value. That value then becomes my approximation for the next x value. So that means f of 1.2 is approximately 3.4. And then I continue this process until I get to the very end, and that's the one I'm trying to find is f of 2. Once I find that, then I can write my answer of f of 2 is approximately 5.8.